killing two birds with one stone. It's exactly what SpaceX could obtain to do a virtual booster tower catch in Starship Flight 4. First of all, they come closer to the real catch attempt on Flight 5. Secondly, they can test the ability to land super heavy offshore. Honestly, several years ago, SpaceX unveiled its intention to land the super heavy booster on a drone ship. Although there are many opposing debates, can't help but mention its great advantages for SpaceX's long-term goals, clearly shown in Starship's Flight 3 in mid-March. Find out everything in today's episode of Techmap. The idea of the offshore landing was considered by SpaceX 2 years ago. A Cape Canaveral job posting in January 2022 hinted at SpaceX's unexpected desire to develop marine recovery systems for the Starship program. In addition to return to the launch site, RTLS, it's no longer clear if those long-stated plans are set in stone, but this idea immediately made the stir. There is likely nothing better than getting the extra performance and increased payload without jettisoning anything like a hot staging ring just by landing downrange. The location for offshore landing could be a platform in the Gulf of Mexico somewhere, assuming that SpaceX built a Mechazilla tower on said platform, and likely on a larger drone ship than is currently used for the Falcon 9 first stage. A conventional launch mission will leave the stage with close to as little fuel as possible by the time it detaches in order to be efficient. But it does not make sense to waste a significant amount of fuel, up to 10%, to make that return to Boca Chica. That number matters while 80% of the fuel is consumed in the first place and the booster just has 20% remaining for in-flight activities. However, keep in mind that this is only a reference to the test flight and the reality is much tougher. Musk partly emphasized it as follows.
Any missions that are going to, particularly to geostationary orbit or to escape velocity, anything beyond Earth is likely to need to land on the ship.
Launches to GEO or Earth escape require too much fuel for the rocket to reverse its horizontal velocity and return to the launch site. It would result in additional wear and tear on the booster. An advantage of ASDS is the vessel can be positioned near the spaceport, so it's far cheaper to bring the rocket back on a ship than to fly it back with fuel, so they can load only as much fuel as they will need to deliver the payload and then mostly fall and glide for a powered landing on the barge. Thanks to that, the rocket's payload capacity is also enhanced considerably as shown in the graph, which is found on the NASA Launch Services Program Performance website. As you can see, Falcon 9 full thrust ASDS always dwarfs its counterpart, full thrust RTLS, in terms of the mass lifted to orbit no matter how far the rocket goes. Most notably, at the altitude between 1,400 and 1,600 kilometers, where the International Space Center is located, the payload supported on Falcon 9 RTLS drops sharply, making the gap much greater. So, the barge in the ocean offers an additional economic efficiency. It can reduce Starship's cost per kilogram. Besides, SpaceX may have to invest in a super heavy ASDS just to refuel its lunar lander fast enough for the Artemis mission. In SpaceX's current plan, there will 4 launch towers only in both Starbase and Florida, and all of them cannot accommodate Starship's high flight cadence in the future, including Artemis 3. Jessica Jensen of SpaceX has recently said that a lunar mission will require 10-ish tanker flights, which seems to support the theory that an Artemis mission would require a full propellant load. According to a GAO report involving Artemis 3 released in July 2021, each launch of a tanker Starship will have a gap of 12 days in between. Assume that 15 is the necessary number to refuel the Starship HLS, with a gap of 12 days in each launch. So, the total days for refueling will be 180 days, meaning each Artemis mission will take approximately 6 months at least to refuel. Not to mention, there will be a lot of plans for Starship at the same time, causing the overload for the launch and landing system on shore. This is weird considering SpaceX's focus on making Starship a rapidly reusable vehicle. Aside from Artemis, SpaceX can utilize these buildings for their long-term ambitions, including point-to-point travel on Earth and serving military and civilian missions. Landing on a drone ship will help Super Heavy become more flexible in landing. SpaceX can land Starship anywhere they want, provided it does not affect other activities in the ocean. This would create a system that had serious utility and wouldn't need to be limited to civilian use. It would be good for the military, good for instant disaster relief, and good for cargo and passengers. And you could have fleets of such ships offshore all over the planet and change them out for maintenance and so forth. Remember, oceans cover a total of 71% of the Earth's surface, so nothing would be better if there were available locations for launching and landing a Starship anywhere in the world. This is useful for Starship suborbital missions, which require transporting large numbers of people and cargo over great distances in short periods. With all the given potentials, why didn't you come up with the idea of an offshore landing structure? In 2020, the company, via a subsidiary, bought 2 retired deepwater oil rigs to convert them into floating launch and landing platforms for the Starship rocket system. The platforms, stationed in the Gulf of Mexico near Boca Chica, Texas, would have enabled rapid launch cadence and flights from optimal locations. Although the project was temporarily canceled in February 2023 because SpaceX was first focused on gaining flight experience with Starship before pursuing sea-based solutions, in October of the same year, they brought the project back from the dead. It does make clear their intention to have the Mechazilla towers at sea. In spite of the given benefits, some people are betting their money every time on the concept of returning to the launch site. For them, it may be possible to build a catching tower on the ASDEs. But in deep water with a tall tower, the amount of sway, pitch, and roll at 50 or 60 meters above sea level is not going to be insignificant, even if the legs are partially flooded, as changes at sea level will be magnified as the height increases above the platform. This will make catching the Super Heavy safely even more challenging and reduce the window when launches are possible. One advantage of offshore landing, increased payload, is also worth noting. The gain in payload would have to be set against the costs in development, extra hardware requirements, delay, and added risks. This would need to be compared against the option of launching 2 Starships from the same Super Heavy cheaply and within a few hours.
Although the concept of reusable rockets has appeared since NASA's Space Shuttle era, SpaceX is the pioneer in taking this concept to the peak. NASA's only reusable rocket project, namely the Space Shuttle, ended in a loss when it failed to meet NASA's standards: low cost, fast turnaround, and safety. Since then, we haven't seen any similar counterpart made by the agency. The reason is very simple. In addition to being incompetent, NASA doesn't use enough rockets to make reusability worthwhile because they are not really in the rocket development business. Reusable rockets are only valuable if the frequency of launches is great enough to outweigh the cost of developing and utilizing the technology. SpaceX is totally different. A commercial space company aims to launch a huge amount of rockets into space. Not only succeed, but SpaceX also can leave NASA in the dust when its vehicles have high safety, short turnaround, and of course, low cost. A typical example is the case of the Falcon 9 rocket. The success of the SpaceX Falcon 9 reusable launch vehicle has been one of the most remarkable technological achievements of the last decade. Powered by SpaceX's Merlin engine, the Falcon 9 booster can be reused up to 20 times, with minimal maintenance between flights. Rockets from the Falcon 9 family have been launched 361 times over 14 years, resulting in 359 full successes, 99.45%. To achieve that remarkable achievement, can't help but mention the contribution of ground infrastructure, serving for launch and especially landing. Currently, the Falcon rockets have been launched from the locations that SpaceX leased from NASA, including 2 in Florida: Cape Canaveral, SLC-40, and Kennedy Space Center, LC-39A, 1 in California Vandenberg, SLC-4E. In 2025, there will be another option from California Vandenberg, SLC-6. For landing, there are 3 options, depending on launch requirements: landing on land, landing at sea, and expanding the first stage. If the mass of the payload is not too heavy, meaning the vehicle has a fuel margin for returning to land, of course, return to the launch site, RTLS, is the best option. Less demanding launches from Florida can return to landing zones 1 and 2 at Cape Canaveral Space Force Station, while less demanding launches from California can return to landing zone 4. But for the mission requiring a huge mass lifted to orbit or to a further destination, such as geostationary orbit or exceeding escape velocity, the rocket will not have enough fuel to return to the launch site. So they can land at sea or, as a last resort, throw away the vehicle. You know, full and rapid reusability is always SpaceX's priority to significantly lower the price of space launch services. And the key early component of SpaceX's objective is an autonomous spaceport drone ship, ASDS, serving for the Falcon 9 booster's landing. ASDS is also part of the multi-year reusable rocket development program engineered by SpaceX. So as usual, the concept of a drone ship will also be applied to Starship. And now, given that Starship's progress has snowballed, it's likely that they are seeking to bring the idea back from the dead. The FAA's presentation about the environmental impact statement for SpaceX Starship at LC-39A, released in June, pointed out that the rocket's stages will land offshore as an additional option. Indeed, Super Heavy can downrange on a drone ship in the Atlantic Ocean, while Starship can have a soft landing on a drone ship in the open ocean between 55 degrees south latitude and 55 degrees north latitude. In this scenario, it's unclear whether Elon Musk will add a couple of landing legs for Starship, but the high possibility is not. If the Little Mermaid sacrificed her voice in exchange for the human legs, what Starship has to sacrifice is its payload capacity. It explains why Musk has vehemently opposed legs for their weight. So, would you like the idea of landing gears on Starship? Share your thoughts. Instead of that, they will redesign the barge to adapt to the huge size and specification of the rocket. Because Super Heavy does not have landing legs, any landing would need a catching structure similar to that at the launch site. Super Heavy is very tall, so would need a very tall catching structure, which would itself need to be afloat and subject to the vagaries of wave motion, as well as the tough weather conditions. So it would probably need a very large barge indeed to keep it stable. Unlike relatively shallow water barges and platforms that can be anchored in or supported from the seabed. Perhaps a deep ocean platform is also an interesting option. For example, Chevron's $500 million Petronas platform is situated about 208 kilometers southeast of New Orleans. It is located in water depths of 535 meters. The rig is a compliant tower and is the largest freestanding structure in the world at 613 meters, double the Eiffel Tower. The compliant tower design was chosen for its ability to withstand hurricane conditions and operate in depths of 610 meters. The compliant tower design enables it to move within an envelope of 7.6 meters sway and a 3 meters rotation sway at the surface. Additionally, SpaceX also handles some relevant issues, such as the transportation from the barge back to the factory for refurbishment. It's really a big matter for the largest rocket ever built. SpaceX is building the launch tower for Starship at LC-39A, and things are about to get really exciting. This site, already famous for its Falcon 9 launches, will soon witness the mightiest rocket ever built. Standing before a colossal project like constructing the launch tower for Starship requires meticulous planning and obtaining the necessary permits. As a result, SpaceX has laid out its ambitious operational plans for the FAA to thoroughly review every environmental aspect of launching and landing Starship and Super Heavy. Now, let's zoom in on the Starship launch proposals that SpaceX has put forward. First off, Starship, after its grand voyage, returns to its roots and lands on the very launch pad that witnessed its ascent. Like a giant robotic embrace, Mechazilla extends its arms to gently cradle Starship and Super Heavy, ensuring a smooth and secure landing. Secondly, just as impressive, Starship will gracefully touch down on an unmanned drone ship amidst the vast expanse of the open ocean. And the final possibility, Starship will make a controlled landing in the ocean, a scenario successfully tested during their historic Flight 4. Yep, that's expendable mode. What really grabs your attention here? Landing on a drone ship? You got the point. Sounds a lot like Falcon 9, right? Starship might land in a way no one has ever seen before. And in this scenario, the landing procedure for Starship will share many striking similarities with Falcon 9. Picture this incredible scene. After a successful launch, the Super Heavy booster gracefully separates and embarks on its journey back to Earth. This journey involves a series of complex but precise maneuvers, much like landing on the Mechazilla chopsticks, the very sight that amazed us in Flight 4. The first stage re-enters the atmosphere at a specific angle to protect the structure from high temperatures. You saw it on Flight 4. The booster didn't fall perfectly vertically, but tilted at about 30 degrees. Meanwhile, the grid fins deploy like a maestro's hands, adjusting every motion to ensure a soft and precise landing. The first stage will gently land on the drone ship, but that's not all. Even the Starship spacecraft, after re-entry, will make a safe landing, performing a final ballet move on a drone ship with the support of an automated control system and landing legs. This moment promises to be nothing short of spectacular. Why can we say that? SpaceX's Falcon 9 stands 70 meters tall from the base to the tip of the fairing. In comparison, just the booster of Starship alone is 71 meters tall. And that's not even mentioning Starship's diameter of 9 meters, 2.5 times that of Falcon 9. You see the differences, right? In the history of space exploration, nothing as large and heavy as Starship has ever attempted a dramatic landing on a drone ship. Once Starship and Super Heavy successfully land, we'll witness not just a new record for size and weight, but also a monumental leap in space technology. This will be a sight to behold, a historic milestone that will capture the world's attention. As SpaceX moves forward with plans to land Starship on a drone ship, we'll definitely see a series of innovative design improvements. To achieve this goal, Starship will need landing legs, a feature that was actually present in the early prototypes during suborbital flight tests. Well, as SpaceX prepares for future missions to the Moon and Mars, landing legs will undoubtedly play a crucial role in these ambitious journeys. However, the real challenge lies in designing landing legs for the Super Heavy booster. This represents a groundbreaking step because the tall, slender booster will require a robust landing mechanism to handle ocean wave motions and remain stable against larger wind-facing surfaces. Imagine it, a colossal booster, taller than many buildings in big cities, gracefully descending onto a floating platform amidst the vast ocean. It's a scene straight out of science fiction. Even more impressively, with the colossal size of the Super Heavy booster and Starship, SpaceX needs to create a larger, stronger landing platform to welcome these giants from the sky. Their impressive diameter demands a solid foundation, a stage big enough to ensure stability for this long cylindrical structure as it returns from space missions. I know some might worry that the dry mass of the booster, over 200 tons, 8 times heavier than the first stage of Falcon 9, poses a major challenge for landing. But fear not, this isn't an issue when we have the massive capacity of the Marmac, a series of drone ships currently being used by SpaceX, capable of handling loads up to 12,000 tons. This incredible lifting capacity really opens up numerous possibilities. The Super Heavy booster with landing legs on an even larger landing platform. How exciting! This will be an extraordinary structure worth waiting for. But did you know this? With its limitless vision, SpaceX considered creating floating sea-based launch platforms in the past. 4 years ago, Musk revealed on X they aimed to build floating, super heavy-class spaceports for Mars, Moon, and hypersonic travel around Earth. Just a month later, this vision started to take shape when SpaceX bought 2 deep-sea oil rigs and named them Phobos and Deimos after Mars moons, with plans to convert them into offshore launch platforms for Starship. The 2 oil rigs were purchased by Lone Star Mineral Development, LLC, according to public records. Lone Star Mineral Development was established in June 2020 and is registered under SpaceX's CFO Brett Johnson. Well, they actually sold them because they weren't suitable as launch platforms, and the company needed to start launching Starship and gain a better understanding of the vehicle before building offshore platforms. However, Gwynne Shotwell told reporters after her presentation at the FAA Commercial Space Transportation Conference on February 8, 2023, that constructing sea-based launch platforms remains part of SpaceX's long-term plan for Starship development. They are aiming for dozens of launches per day, so they will also build floating launch platforms that can withstand a crazy frequency of launches. We'll have many pads. I think we'll have a lot of sea-based platforms as well. We have to see how this ship goes. It's highly likely that once SpaceX refines and perfects Starship, they'll land it on drone ships, and eventually, as they gain more experience, they'll build offshore launch and landing platforms. I mean, these won't just be simple barges. They'll be complex, sturdy, and fortified bases with comprehensive support systems. This approach will drastically reduce the downtime between flights and pave the way for continuous Starship operations. A completely new approach compared to the current Falcon 9 process. At the present time, After a Falcon 9 lands, SpaceX has to bring the first stage back from the middle of the ocean, inspect and refurbish it before the next launch, a process that takes several days. But with a dedicated offshore facility for Starship, things will be entirely different. This will be a giant leap, a complete revolution in the space industry. However, Starship's growth has clearly made other launch companies seem small in comparison. Blue Origin quickly attempted to halt SpaceX's progress by sending a 3-page petition to the FAA right after the draft EIS was released. Interesting, right? Let me summarize the highlights for you. Utterly predictable, they expressed concerns about environmental performance, the safety of local personnel and properties, and nearby areas regarding Starship operations, including routine activities and unexpected incidents. They even suggested limiting the frequency of Starship launches, landings, and other activities. Additionally, they proposed cutting government spending and private investments in the project to reduce tension with other launch service providers. For the grand finale, they want SpaceX to be held financially responsible for any third-party losses caused by Starship Super Heavy operations, including commercial disruptions. In other words, they think SpaceX should pay them whenever they can't get their job done. Well, Blue Origin is a major company that had a 2-year head start over SpaceX and still hasn't launched anything into orbit. Maybe it's time they focused on their own success story instead of attacking others. After all, their lawsuit history is becoming more impressive than their launch history. If they keep prioritizing press releases over product development, their position will be firmly beneath Starship's feet. Despite rivals' attempts to throw a wrench in the works, Starship is gearing up for an attempt to land on Mechazilla arms during its 5th flight, anticipated by the end of July. It's set to be a spectacle, a hell of a sight to see, so stay tuned for it. Well, that's it for today's episode. Thank you so much for tuning in, and we'll see you next time.